So one of the most interesting concepts around automatic recovery is doing automatic recovery with leader election. Now the way I put it is leader election is the base condition of your recursion. Let me talk about it. Hypothetically, let's say you have a bunch of servers that are serving HTTP request, right? And now if one of the server goes down, another server comes back up. But who does that? Let's say there is a component called orchestrator, right? Orchestrator's job is to do that. Hey, if one of the server goes down, I'll spin up a new machine and put it behind a load balancer, which is what this orchestrator is doing, right? So this orchestrator is keeping an eye on all the three servers that are behind the load balancer. If one of the server goes down, this orchestrator spins up a new machine and puts it behind a load balancer, right? Okay. So orchestrator is the one which is keeping an eye on the server, right? But who's keeping an eye on orchestrator? So you need an orchestrator for the orchestrator, but then who's keeping an eye on that orchestrator? You need another orchestrator for that. So where does it stop? This is where leader election comes in. Leader election is a way for you to auto recover from failures. You need almost zero human intervention. You need zero human intervention to recover from failures like this. This is importance of leader election for automatic recovery, right? Okay, let's take an example to understand it really well. So in a leader follower setup, instead of having one orchestrator, we would have an orchestrator leader and an orchestrator worker, right? So we have an orchestrator leader, we have another which is orchestrator worker. Orchestrator worker is the one that is keeping an eye on the servers. If one of them goes down, orchestrator worker is the one that would spin up one and put it behind a load balancer. Orchestrator leader is the one that is keeping an eye on orchestrator workers. In case one of the worker goes down, leader spins up a new worker and it spins up a new worker and makes it do the work that an orchestrator worker is supposed to do, which is keeping an eye on this thing, right? So this is how you are ensuring if this goes down, taken care of. If one of the orchestrator workers goes down, orchestrator leader takes care of. But now what happens when leader goes down? When leader goes down, which is where all the existing orchestrator workers, they would do leader election and make one of them the leader, and your system automatically recovers. Why? Because you didn't have leader, there was no one to monitor it. Now one of the workers promoted itself to be the leader, which is where leader election algorithms kick in. In distributed system, there's concept of leader election algorithms. Just Google search away, pick your favorite leader election algorithm and make your orchestrator leaders and workers follow that leader election algorithm. So when any of the worker figures out that, hey, leader does not exist anymore, there would be a leader election algorithm kicked in amongst the workers, electing one of them to be the new leader. And your system again restores, because now your system is auto recoverable, right? Because if one of the backend server goes down, orchestrator worker would spin back up, right? If one of the orchestrator worker goes down, orchestrator leader is doing that. And when orchestrator leader goes down, workers run a leader election algorithm and make one of them as the new leader. So here, with zero human intervention, you are ensuring very high availability of your system. This is the beauty of leader election. This is where leader election actually comes in. And now you understand why I said what I said, that leader election is the base condition of recursion. Because you would have a component to monitor something, but who monitors the one who monitors? You need another one. Then who does that? Then who does that? Right? Which is where at one point in time you stop and apply leader election. That's the job of leader election. When you configure those systems such that where your system is auto recoverable from a node failure, that's where is the base condition of your recursion. That is exactly where you stop, right? And now your entire system is basically auto recoverable. You don't need any human intervention whatsoever. And your system is just highly recoverable from any sort of failures. And this is where you use leader election for auto recovery from failures, right? This is a very generic concept, right? Leader election algorithm. So what I would encourage you to do is read about leader election. And now you can relate what you're reading about leader election in this context. Like, why do you need leader election? This is why you need leader election. Because leader is keeping an eye on worker. Worker is doing the grunt work. Right? This is what leader election is all about. This is exactly how you work at your job. You have a manager, you have a bunch of teammates. Manager typically takes care of stand-up. But if the day manager is absent, one of the employees, one of the team member becomes quote unquote manager and drives the stand-up. So no matter what happens, your stand-up never fails to happen. There is always someone stepping up temporarily to become the leader and does that job. Right? If your leader is off for, let's say, a month, that person will continue to do that. Right? If leader comes back up, he or she can take its place back. Otherwise, she would continue to function. Let this become like this person take care of stand-up. That's exactly how this is modeled. Right? And now you know why you need leader election and where you can put it handy, or where it actually comes in handy. Right? To make your system auto recover from failures is the key job of leader election in general when you put in any distributed system. Right? So read about leader election, read about leader election algorithms. There are many out there. Bully is the best one, the most simplest one out there. Read about them. You'll have quite a good time doing it. If possible, it's a stretch, implement one. It's not really difficult to implement one, but try implementing one just for fun. And you don't need distributed systems for that. Just a hack for it. And I'll also add it in this note, just a hack for it, that the workers that you would spin up, create multiple threads instead of multiple machines. Let each worker be a thread and let one of the thread kill itself. And then let the master thread kill itself, or the leader thread kill itself. And then you would see the leader election happening between other threads and one of them becoming the leader. Right? You can simulate it without having a need of multiple machine and doing distributed system between that. Just use threads to mimic leader election. Right? You'd know how that thing functions and how your system is auto recovering from failure. You'll have very nice time implementing it. Right? And yeah, this is what I wanted to cover about leader election for auto recovery. Right? You see how you need zero human intervention to recover from failures. Yeah, and that's all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. I'll see you in the next one. Thanks a ton.